Hello and welcome back to European Research Showcase. My name is Sam Langford. I'm the coordinator for the Global Science Show, putting together today's event as part of Intersections 2023, a UKRI funded project showcasing researchers from across the European Union. And I'm so delighted to be back with another guest to find out who they are, what they do, and why they're awesome. But before we get to that, please do hit that like button. Please do share any of the content you're seeing as part of the showcase today. But first questions first, Cristina, who are you and what do you do?
Hi, thank you very much, Sam, for inviting me. I'm Cristina Perez Becceril. I am a researcher at the University of Manchester. I mainly do research on genetics and neuronal disorders. I started my research doing investigating genes associated with schizophrenia, and now I'm kind of working on tumor predisposition syndromes. That's basically it in a nutshell.
So how do you end up in a job like that? Can you take us through the career journey to where you are today?
I mean, I always liked asking questions and investigating and sort of trying to come up with questions with the answers to the questions. My dad is a chemist, he's a chemical engineer. So since I was really young, I thought I was going to do chemistry, and I went on to do chemistry at university. And when I was doing that, I thought, but I really like the brain. This is really cool. And I really started to look into genetics. And so I applied to PhD programs, and I got a place at Imperial College doing exactly what I wanted to do. And it was kind of like really lucky. So I started looking into genetic predisposition to different disorders. And at the moment, I was also really fortunate to find this project I'm working on in Manchester, and I'm very happy to do that. But yeah, it was kind of like very, I don't know, it wasn't really like a very straightforward. It was kind of always sort of like, oh, I like to do this, and oh, but I think that looks really good, and just trying to find a way to do it. That was it.
It's something that whenever I speak to academics about that career journey, they always seem to go, oh, I don't have a straightforward route. I think no one does. Like, everyone has this, oh, I really like that. Maybe I'll explore it a little bit more. So it's definitely something that seems to happen to so many folks working in research. What does an average day look like then? Is there an average day for you?
Mm-hmm. It depends on the time of the year. At the moment, my average day is basically kind of writing down sort of ideas and doing a lot of proposals to kind of apply for funding grants. So it's getting into this. This is what I'm planning to do in the future. But also, I mean, at the moment I'm working on, I would have experiments. So I would go in the lab, have experiments. I work with cells that we culture in the lab. That's really nice. I really like that kind of work. Sometimes I would also have students. So I get to work with students that come to the lab to do projects, like small projects, depending on the degree. Sometimes it's undergraduate students or master students. And so I would just show them what we do, how we do it, to kind of guide them throughout the process in the lab. I would maybe prepare presentations. Sometimes we have conferences, which is a lot of fun to go and talk to other researchers and see what they're doing and get really excited about the other people's work and share what we're doing. But yeah, I think it varies, but those are the kind of main things that I would probably do at different levels in a day.
It's something I want to pick up on because I just find it fascinating. When you mentioned about working with cell cultures in a lab setting, what exactly are you doing there? So it changes lab to lab.
Yeah. So because I work, so the syndrome or the disorder that I'm working on, it's a tumor predisposition in Schwann cells, which are the cells that kind of coat the nerve, so to kind of make it insulated and so that the signals go through. And so there are changes in very specific genes that cause these cells to become tumors. And they're usually benign, but they're also very disruptive for the people who suffer these disorders. So sometimes they cause intractable pain or deafness, depending on where the tumor is located. So we work with Schwann cells specifically, And so I didn't make them. So somebody else in a different lab and very kindly sort of donated them to us. But what you do is basically start by getting a little bit of tissue of the that you're interested. So in this case, nerve tissue, and just kind of isolate these specific cells, Schwann cells, and then modify them so that they continue growing. And so that's what we do, so that we kind of feed them in the lab. And what I do is modify them. So I kind of introduce these changes in these very specific genes, and then have a look at what happens afterwards. So I look at, for example, what happens with this particular gene. Does it get more activated or less activated? Does it make more protein or less protein? Are there other changes in other proteins that happen because of these changes in the... And so just to try and work out how these variants or how these changes in the genes are leading to the tumor, so the formation of these tumors. And eventually, well, hopefully to try and prevent them. But at the moment, my work is mainly to understand these variants, and then also to try and identify them more easily when patients come through the screening service. Yeah, and just to kind of be able to say, yes, that's definitely the variant that's causing this disorder.
Oh, yeah, that is something that I think is really important for us to think about when we're speaking with public audiences, is the application of the work that you're doing. So if you're able to identify these kind of gene disorders, is that directly able to link over to screening then? Is that the plan?
Yeah. So Manchester, I'm kind of flying the flag, but they have so the NHS the genetic screening service is very good, and they have their own protocols. So we're not really directly involved in diagnosis, but in some cases they will. So a patient would come through, they would go through the process, and the clinical team would find some variant in a gene that we know it's implicated, but they don't necessarily know whether that's doing something or not. So they're kind of thinking it might be, but it might not be. So we don't necessarily know. So then I'm working on these kind of variants, so that eventually we will definitely know, yes, that's the variant. So that then you can report it to the patient and say, this is what's happening. And then it helps as well, because these disorders tend to be kind of passed down as well. So it's useful for them to know, for other members of the family or later generations. So that's, that's a process that's kind of already happened, but I'm trying to work on variants that we don't know for sure what they're doing, if they're doing something. That's the kind of beauty of the genome, that there's so much variation. There are so many things that are not equal for every person. And some of them are just, random changes, and they're not really doing much. And some of them are. And so it's just kind of working out which ones are doing something specific.
It sounds like a really intricate puzzle trying to be solved, which must be great to be involved in that sort of work. We're rapidly running out of time though. With these, it does just fire away from us. So the last thing I usually ask is, if you had 30 seconds, like an elevator pitch, to tell people something about your work, what would be the one thing you'd want them to know?
I love for them to know that this is a very normal job. That it is exciting, obviously, and I'm really excited to go. But I also think sometimes we think of science as a sort of like overly over there thing, and I think you go through the same steps maybe that you would do with other jobs. You do kind of the training, you do the very specific steps, and so it generally is. There are so many different people, like that come through the lab that kind of like pour their love and passion and their talent into it, and we're always better for it. So generally, it's a very sort of normal. If you're interested, if you want to do it, it's not a very mystical sort of. Sometimes I do say molecular biology is a bit of a black magic thing, because you can't see something and you kind of work with little things. But no, it's very normal. It's very so we're all very normal people. So I think that's the thing that I would like them to know the most, that if you would like to do that, it is possible. It's not. you don't have to be special or have very specific aptitudes. I think it's just generally mostly interest and just curiosity, I think.
A really great note for us to finish on. Where can people find out more about you if they want to keep up with the work that you do?
I think I'm on Twitter mostly, and on Instagram as well. I think those two are the main places where I would normally come out and talk and socialize.
Fabulous. And I've made that appear on the screen.
Thank you very much.
Cristina, thank you so much for coming to tell us about your work.
Thank you.
Yeah, an absolute delight. Thank you, folks at home, for watching.
Oh, thank you. It's been a pleasure.
If you've enjoyed what we've been talking about this morning, please do, again, as I said, hit the like button. Please do share. And please do continue to engage with all of the things coming out as part of the European Research Showcase. We've got so much that's going on. But for now, thank you so much, and we'll see you all again very soon.